Assalamualaikum. My name is Haris Iqbal bin Muhammad Ridha. My ID is MH22014 and I will explain about kinematics about the auto folder gate system. First, based on what I know, kita ada 3 jenis auto gate system. First, auto gate yang akan buka penuh. Second one, auto gate yang jenis akan buka dari kiri ke kanan. Dan yang ketiga ni yang based on the project, which is dia akan lipat separuh sahaja. So based on FBD yang ada kat skrin sekarang ni, kita orang menggunakan reference pagar yang belah kanan. Kalau lihat pada situ, O adalah center of rotation. So O adalah fixed point, mana velocity pada O tu dah kosong. VA pula dia akan bergerak ke arah kanan, and VB pula dia akan bergerak selari dengan bentuk pagar tu, iaitu ke bawah. Dan kalau kita tengok kepada kinematic diagram ataupun KD yang ada kat skrin sekarang, omega BO akan bergerak ke dalam, iaitu menghala ke arah menutupi pagar. Sama juga dengan omega AB, which is dia akan bergerak ke arah menutup pagar juga.
Alright, for the gate, we are choosing a gate that we obtained the picture from the Google, which is this gate, and we also get the dimension from the description we get on the website, which is each part of this gate is the length is 1.5 meter, which is from this point to this point is 1.5 meter, and from this point to this point is also 1.5 meter. And we also get the video of the folding gate, which is this one. This is the video of the folding gate that we get from the Google. And in the website, we also get a description about the velocity of the piston that the gate is using, which is 20 millimeter per second.
Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Haris bin Muhammad Faiz, MH22003. So I will present about for the question 3 and question 4 about the coding. So we start about for the question 3. So first of all, we all know we have to draw the FBD as we have learned in our lecture. So from the FBD, we know that let's say I'm assuming it's closing because the question asks the angular velocity, the velocity of A while it closed and open. So I'm assuming it's closing, which means the gate will move to the left and the VB will go down to this side and VA will move to this left side. So proceed to the information we have from the data of the gate, which is velocity max piston. Basically piston is on here, 6.0. So the velocity is 0.02 meter per second. So we insert this to this basic equation, V equals to RW, and we took the omega of OB and the R of OB. So the R of OB is 1.5. Insert this value to this equation, and finally we get omega OB is 0.0133 radian per second. So knowing that this gate, two of the body gate is from the same piston power, so the angular velocity, I'm assuming that it is the same. Omega of OB and omega of VA is 0.0133 rad per second. So moving on to the second equation, which is the famous equation of vector. We choose VA equals to VB plus VAB. So VB we didn't know yet. So from that we have to make another third equation, VB equals to VO plus VBO. So we know that VO is 0 because it is fixed point. And the VBO we can find the velocity by using R omega, and the RBO, which is the direction of O to B, negative I positive J. So from that we can conclude that negative 1.5 cos theta I plus 1.5 sin theta J. And after we got the final equation of VB, we insert back to this equation. So for the VAB same goes like VB just now. We can find the RAB from the FBD, which is movement from B to A, negative J, negative I. So we conclude that negative 1.5 sine theta J minus 1.5 cos theta I. So the omega we use is the first one we find, 0.0133K right here. So after calculate all of this, we get the final value of velocity A, negative 0.04 sine theta I. So we make a comparison of I component, we finally get the average velocity of VA, which is equals to negative 0.04 sine theta.
Jadi kalau kita lihat pada rajah kinematik diagram tu, omega BO bergerak daripada arah kanan ke kiri ataupun dikenali sebagai anti-clockwise movement, manakala omega AB bergerak daripada kiri ke kanan, dikenali sebagai clockwise movement. Jadi untuk memulakan ataupun menyambung kiraan velocity midpoint ini menggunakan kaedah vektor, beberapa info daripada average velocity perlu diambil, which is VA tu equals to negative 0.04 sin theta, omega pula 0.0133, RC respect to A ataupun radius daripada A ke C adalah 0.75 meters. Jadi kalau kita pecahkan mengikut vektor punya solution, VC equals to VA plus VC respect to A. VC dan VA mempunyai arah pergerakan yang sama, iaitu kalau mengikut komponen ia adalah pada komponen I. So pada line kedua, VCI sama dengan bracket negative 0.04 sin theta I tambah dengan omega AB, iaitu omega tu adalah dalam komponen K. RC respect to A ada dua komponen, iaitu negative I dan juga negative J. So pada line ketiga, VCI sama dengan bracket negative 0.04 sin, dan kita masukkan theta kita iaitu 30 degree. Komponen kita adalah I, tambah dengan 0.0133 komponen K, darab dengan negative 0.75 sin 30 degree J minus 0.75 cos 30 degree I. Untuk line keempat, VCI equals to negative 0.02I plus 0.00499 I minus with 0.00864J. Untuk mendapatkan VC, kita kena pecahkan kepada I komponen. Jadi kalau kita bawa keluar semua komponen yang ada, untuk I komponen, VC adalah bersamaan dengan negatif 0.02 plus 0.00499. So VC kita akan dapat negatif 0.01501 meter per second, ataupun kalau kita round off, kita akan dapat negatif 0.02 meter per second. Thank you.
Alright, move on to the next method, which is IC method. As for the IC method, first we need to draw the FBD, which is like this, that we obtain from the gate. And then we need to find the IC, which is, the first thing is we need to make a straight line that perpendicular to the both of the velocity, which is VB and VA, so that we got this line and this line, and the intersection point of the new lines will become IC. And first we need to find the RBIC and RAIC. As for the triangle we obtain, all the angle are the same, so if we are using the sine rule, we will get all of them as the same length, which is 1.5 meter, 1.5 meter and 1.5 meter. And as the question asks us to find the velocity of the midpoint, which is this point C, I made a new triangle from C, IC and VA in A, which is, it will become like this. And what I do in this solution is, first I find the RCIC, which is using the sine rule. RCIC square equals to A square plus B square minus 2AB cos theta, and I get 1.3 meter as the RCIC. Then I find the VA, which is, I find the omega BA, as VA is already obtained, and we also already get the IC. as I calculate, I get the omega BA is negative 0.013. And then I submit into the VC equation, which is VC equals to omega BA RCIC. And I get negative 0.02 as meter per second as my final answer for VC.
Okay, for the next part, we're going to find the midpoint of AB. We denote it as VC. So for this, we use the scala. First, we draw the FBD. We know this O, B, and A. So the point C is here for the midpoint. So this is the same value, and the question is when the degree is 30 degree. So first we know that VA equal to negative 0.04 sine 30. So we calculate it, we get negative 0.02. Next, VB in the direction is when we draw the OB line. So the direction is perpendicular to OB. So this is VB. Next is the VAB. VAB, so BA. VAB is when the B point is fixed. So here also perpendicular. Then we can draw it to solve for VB. We find VB first. Angle here we know that is 60 because here VB is perpendicular like this. Next, so 180 minus 60 and 90 is 30. So here is VA because VA direction is here. VC we do it as like this. VC VB like this. So to find the VB, we use the sine rule. This is 90 degree. VB sine 30 equal to negative 0.02 over sine 90. So VB is equal to negative 0.01. So next, we can use the VB to find the VC. VC direction is like VA. Okay, we draw the VC and the VB. VCB here. The degree here is 60. Is actually the same. So here 90 and 30. So we use sine rule also. VC sine 90 equal to VB here. We already get it, so we masukkan 0.01 sine 30. So the final answer for VC is negative 0.02 ms/1. Okay, that's all from me. Thank you.
Question number 4 about the coding. So I'm using Python programming program, and first of all I use 4 import types, which is map, graph, numpy, and time. So this is the starting of my coding. For the data, I'm using the array to let it run automatically from theta 0 to theta 90. So basically, for the value of sine, the sine we know that it is in angle. So we have to convert it to the radian to make it easier calculation. So after we convert it, we use the equation of V equals to RW to find the omega angular velocity of body OB and AB. So from that, after all of data have collected, the this coding, this program, it will display the graph that will show after this. So this is the coding plotting graph. So let's run this coding. So enter your name first. So see here, this is our graph for our project. So we look at here, the body OB, the orange one is positive. The body AB, omega AB is negative. So let's confirm it. We know that omega BO moving anti-clockwise, which means it will become positive OB. OB is positive. And AB is clockwise, it will because be negative. So AB is negative. So we can conclude that this graph and this coding is running correctly. So that's all for me. Thank you.